tremendous advancements in our understanding of the life cycles of stars. Stars are just like human beings. They're born, they evolve, they change over time, eventually they die. These are three beautiful pictures the Hubble Space Telescope captured of the process of stellar death in different stars. The picture that you see in the top left is a picture of a star. Doesn't look like a star, but that's a star. That's what happens to a star after it exhausts all of its nuclear fuel and its gases start getting expelled into space because the equilibrium between pressure and gravity is broken. This is the end fate of our sun. Our sun will swell up to be a size that's so big that the orbit of the Earth will be inside the sun. That's what happens to stars in the end stages. The middle picture shows a picture of Eta Carinae. That's a star, a single star, that's about 70 times heavier than the sun. And this star is about to blow up as a supernova. And what you're seeing there is gas that's been expelled from that star prior to that explosion point. Pretty soon this star is going to go boom. Picture that you see in the bottom right, that's what happens after the supernova. It's a supernova remnant. So thousands of years after the supernova explodes, there's an expanding spherical bubble. Imagine a sphere, like a ball, that's expanding into space that contains all of the products that were generated in that star. And it's this process that's actually responsible for how we got here. When the universe first formed, the universe contained hydrogen, helium, and a tiny amount of lithium. All of the other heavy elements, the skin on your bodies, the wood on this table, the plastic in my laptop, all of those elements, those compounds were created in the cores of massive stars where you fuse heavier atoms together. And then when the star blows up, it takes all of those materials and spews it into its surroundings. When next generation stars form, like the sun, with planets like the Earth, they're already contaminated by those heavy elements. And that's why life started on our planet. If we step out from the nearest stars and look at the nearest galaxies, this is a beautiful picture of the Andromeda Galaxy. This is the same galaxy that Edwin Hubble looked at to infer the expansion of the universe. But this is how we see it today with the GALEX telescope, a space-based ultraviolet telescope. So let's zoom out here and look at what this galaxy looks like relative to what we would see with our naked eyes or with a small telescope. That's where that galaxy sits in the night sky. This is how you might perceive it with your eyes. And it is a galaxy that you can see from a dark location with the naked eye. So let me zoom in now and show you how Hubble views this galaxy. What we're going to do here is zoom in towards this galaxy, and what you'll see is as the resolution starts to run out on our ground-based views, our ground-based telescopes, Hubble's only getting started. Once we zoom in far enough, Hubble can actually break the individual stars that are in this galaxy apart from one another. So in this image now, you're seeing stars that are separated by a light year. So these are stars that are separated by the same distance as between the sun and the nearest star to the sun.